Okay, in 3.2, we're going to introduce complex numbers. And as you know, not all quadratic equations have real number solutions. For instance, if I were to solve this and take the square root of both sides, you can't find the square root of a negative number. A quadratic equation that doesn't have real root solutions looks like this, because this particular graph never crosses the x-axis. Quadratic equations that have their vertex on the x-axis, there's one solution, one real solution, and then if it crosses the x-axis twice, you know you're going to have two real solutions. But we're going to talk about this scenario right here for now. Okay, to overcome this problem of those quadratic equations that don't have real number solutions, mathematicians created an expanded system of numbers using the imaginary unit I. What is I? I is equal to the square root of negative 1. So in that case, then I squared, if I squared this, I get negative 1. I squared is negative 1. So for example, earlier I said you can't find the square root of negative 3, but you can if you use imaginary numbers. So the square root of negative 3 is the square root of negative 1 times 3, but we've just determined that the square root of negative 1 is actually I. So the answer to this would be I square root of 3, and that's how you say that. So a complex number, this is standard form for a complex number. A represents the real number part, and BI represents the imaginary part. A pure imaginary number is when A is 0. So 3i would be considered a pure imaginary number. Again, A is the real part, B times I is the imaginary part. In that 3.2 worksheet, you're going to have a section that says, will tell you to find the values of x and y that satisfy this equation. It's a lot easier than it looks. So we have 2x minus 7i equals 10 plus yi. So the first thing you do is you're going to equate the real parts, set 2x equal to 10 and solve. So x is 5. And then the second part is you're going to equate the imaginary parts. So negative 7i equals yi. And I can see to make these equal, y has to equal negative 7. That's your introduction to imaginary parts. Just know that you add and subtract, multiply and divide just like we normally would. For instance, if I had let's just use the numbers we had before. 2x minus 7i plus 10 plus actually we're going to use different numbers. I don't want 2x, I want a real number there. Sorry. Let's make that 5. So we're just going to add the real parts. 5 plus 10 is 15. And then we're going to add the imaginary parts. Negative 7i plus 5i is negative 2i. Let's say we're going to multiply. Let's do use the same values, only this time we're going to multiply those two binomials. Alright, we're going to FOIL this. just like we normally would when you're multiplying two binomials. The first product is 5 times 10, which is 50. The outside product is 5 times 5i, which is 25i. We're going to do the inside product, which is negative 7i times 10, which is negative 70i. And then multiply the last terms. Negative 7i times 5i is negative 35i squared. But don't forget that if I equals the square root of negative 1, then I squared equals negative 1. So we're going to replace that with negative 1. Negative 1 times negative 35 is a plus 35. So 50 over there. We can combine these two. The difference is 70 and 25, 45, and it's negative. And now I can combine these two numbers, the constants. So my final answer would be 85 minus 45i. Remember that when you're writing complex numbers, you always put the real part first and the imaginary part second. And that's considered standard form. All right, we'll do more of these examples in class, but that's pretty much it for 3.2.